Okay guys, check this out. We have a Choropleth map here that we built very quickly with Python and Plotly, and we can see all of the per capita income measures for each of the counties by FIPS number there. And we were able to very quickly change and show the unemployment rate for 2017 also by FIPS number. And so we can hover over any of the counties that we want to take a look at in different parts of the country. And we also did mean work travel, and we added the county name into our hover over for this one just to take a look at some of the features we can add very easily once we get started. This is a very simple kind of map to create with Python and Plotly, and it's what we're doing today.
I'm your host, Sean MacKenzie. Thank you for joining me once again on my channel on data engineering. In this episode, we go back to our Python playlist, and we're going to take a look at maps again. Now, in a previous episode, I did an interactive map that allowed you to zoom in and look at all kinds of data points that you could put on a map. And in this episode, we're going to take a look at the Choropleth map. Now, a Choropleth map is very handy because it allows you to show statistics across regions, and you can see the differences between the statistics in each region and do comparisons, and it's also quite interactive, and that makes it really great. And once again, we will be using Plotly for this exercise today. Let's go make a Choropleth map. Let's get to it. Interested in more cool topics like these? Make sure to check out my Patreon. The link is in the description.
Okay, let's get started. Here is our development directory, and many thanks to OpenIntro for this data set today. We are going to use the county complete data set, which is available at the URL that you see above there, and it has all these wonderful statistics that have been compiled, and they've been put together into this CSV file. You can also get it in other formats if I scroll down here. So this is fantastic because we also have a data set that shows our geodata, and we will also be using that, matching it up to this data set. So this one here, you can see this is where everything comes from, and you can download it just by clicking on CSV. You can also get those other types that you see there, and so once you download it, that's what it looks like. So here's our directory. We're using this cdev map Choropleth directory, and if I open up this file here, it'll open in Excel. We're not going to convert anything. Don't let Excel ever do anything to your data automatically. That's a big no-no in data engineering because Excel will do weird and wonderful things. And this is our data set here. We can see there are a great number of rows. One thing to look for is the 5-digit FIPS code, which is 4 digits. You might remember when we were scrolling there. We'll go back up here. There's our FIPS, and you can see that those are 4 digits and they need to be 5 digits, so we're going to account for that. I chose this broadband. I just did a search there. I think this is a good one to start with. So we'll look at this, who has broadband internet in 2017 in each county, what the percentage is. And if you scroll down, you can see that there's kind of a neat variation here. We will also be looking for the maximum and minimum number in the chosen column. So we're going to make a dynamic script that finds the maximum or minimum of the chosen column. Now if we scroll to the top here, you can see all these wonderful fields that have been compiled in this data set. You could have a lot of fun with this. There's all kinds of unemployment and who has computers and different kind of measures in here. If you open some of these columns here, if I open these, you can see age over 85, age over 65. So you can really get a sense of what's going on in each county, and you can plot these, of course, to our Choropleth map. Okay, so next we are looking at the GeoJSON data that makes up all of the county borders and things, and that's going to be in this JSON file that you can get from the URL above. It is freely available and is part of some of the demos that they do with Plotly to do Choropleth maps. And so we're going to be using that one in our demo as well. For that file, it's not mandatory to download it since we'll reach out with our Python code and get it directly. And that's how we'll be using that one today. Okay, let's go ahead and fire up our idle shell, or if you're using, Jupyter Notebook or something like that, you can go ahead and start that. The code is pretty much the same. We're going to start a new Python file here. So let's pull that over onto our window here. And there we go. So we've got a new Python file. I'm going to save that into C, our development directory that I pointed out before. So now we have two files in there. We have the county complete file as well as our Python file. And that's going to get us started. Okay, let's do some imports now. We'll use from urllib.request. We're going to get URL open, and that's going to allow us to grab that JSON file. And we'll also be using JSON, of course. And then what we can do is we'll use a with statement, and we'll grab that JSON file. This is kind of the easiest way to get it. You can also download it and use it using an open statement, which I will show for the next file. But for this file, we'll use the URL open, and we'll paste in that URL that I showed you in the browser before, and we'll do that one as response. And so we'll have a response object there, which we can do something with. So in this case, what we'll do is we'll set our counties variable equal to the contents of our JSON, and we'll load that using json.load response. And so that call is going to get all of this data here, and it's going to load this this JSON data that you see here. It's going to load that up into a variable for us that we can use on our map. Okay, next what we're going to do is we're going to set up our variable that we want to pull. So the column from that from the CSV file that we want to make it dynamic so that we can change the field for our mapping so that we can look at different kinds of comparisons on our Choropleth map. And so we're just going to say field equals broadband 2017. That's the field that I showed you early on when I was showing the data set there, and that's going to make it nice and easy so we can change that value of that field variable, and then we'll get a completely different map because it'll be different data. Now we are going to use pandas, so you might need to go to your command console here or your PowerShell window and do your pip install pandas if you do not have that yet. Hit enter after you type that one in, and it'll go get that directory. I already have pandas in my installation, so I'm not going to run that, but you could run it on yours in order to get that installed. And we're going to use this import pandas as PD here, which is going to give us pandas, which is a wonderful library for doing all kinds of analysis and having data frames in memory. And we're going to get our CSV data via pandas. So we'll say data frame, or df, equals pd.readcsv, and we'll put our countycomplete.csv file as the argument there. We're going to set a data type for that first column because we don't want it to be a number. We want it to be text because it should have leading zeros on it. And we're going to put those on in a minute because I saw that Excel at least doesn't want to show that. It could actually be that those are in the data if we looked at the data using Notepad instead, but we're going to make sure of that. And we'll set the header equal to 0, the first, which is the first row. That's going to have the column names, and so there we go. We've got our county complete. We set our data type of the FIPS column to string, and we want to get that header column as 0 so that it doesn't interpret it as data or something like that. And so we want to make sure that we don't have any misunderstanding with our data set there. And I'll just take a moment here to show you this file again. So this is the countycomplete.csv file, which is in that directory there. And you can see I say don't convert, but we have values in here which are showing as 4-digit values. Now we may not need to do this. We could open this in Notepad and check to see if those have leading zeros, but it's supposed to be a 5-digit FIPS code, and that should have a leading 0. So we're going to make sure that that happens, and so we can do that in our code here. So we'll go back and we are going to modify a column in the source data frame. So we'll say that that FIPS column, we're going to modify that. We're going to make sure that it has 5 characters including leading zeros. So if we find any that don't have those leading zeros, we're going to pad that with a 0. And so we'll set it equal to the FIPS column, and we'll use the pad function there. We're going to set that that value. So there's our column. We're going to set it to itself using the string method here with padding, and we're going to make sure it's 5 characters long. On the left, we're going to pad it with zeros if it's not 5 characters long. And then the next thing we'll do is create another data frame based off of the first data frame, and we'll call that one DFX, and that will be equal to 2 columns because we only need 2 columns for our Choropleth map. We need the FIPS column and the field column. We'll add some more columns later, including the names of the state and things like that. But for now, we're going to grab that data frame column, the FIPS column, and whatever field we chose. So there's the field, and right now that's set to broadband 2017, but we could change that and run it again with a different field name just by changing that variable up top there. And so next what we'll do is we're going to import Plotly, and we'll be using Express, and we'll use an alias for that, which is px in this case. So we'll say plotly.express as px, and that's going to give us something to work with for our figure. And so we'll say our figure is equal to px.choropleth, and then we'll have a bunch of arguments for creating our figure. The first one will be our data frame, our source data frame, which is the DFX data frame that only grabbed 2 columns from our big source data frame there. And we're going to set our GeoJSON equal to counties, which is the field up above there that we loaded with URL open. And we'll set locations equal to FIPS. That's going to be the FIPS column there, and that's going to give us nice boundaries and everything for all of the counties. And we'll set the color equal to the field. Now, so the field, remember, is dynamic, and it'll change depending on which field that we choose. So the color will sort of range, depending on the numbers in that field. And we'll use a color continuous scale, and that's going to be kind of a named scale. So we have lots of options there. I'll show some of those to you here in a sec. We'll choose rainbow for now. That's a nice easy one to use, and we'll set the range color equal to the minimum of whatever the field is to the maximum number of whatever the field is. And so in order to do that, we can simply get the minimum of our DFX field to the maximum of our DFX field in order to make that tuple there of the range color. So that's going to set a whole bunch of things in our output, so that the range, so the color will also be changed by that, but also the scale will be changed by the minimum and maximum and things like that. Now we're going to put scope equals USA, and that's going to narrow so we don't see the whole world and then just colors inside of the United States. We're going to actually just set the scope of our map to just show the United States. And then we'll do figure update layout, and let's put a margin in there just so that we don't have any big automatic margins. We'll set those to 0 for now. So we'll set our margin equal to right 0, and then we'll do our top 0 and our left 0 and bottom 0, and that's going to add the margin 0 margins to our little output there that'll come out in the browser, and that's going to make a nice little graph for us. Now you can adjust those if you need to put additional margins on, depending on how you want it to look, but there's our little dictionary for margin, and that's what we want to do. So all we have to do after that is just say figure.show, and we should get something. So let's save that and take a quick look at our code here. Now the continuous scale that I talked about before, you can find that on the Plotly website. I'll pull it up here so you can see it's in that URL there, plotly.com, built-in color scales. So there's lots of neat kind of built-in scales that you can use. Of course, you can make your own, I'm pretty sure, but these give you lots of options if you want to have sort of a wider range or different range of colors in your Choropleth map. We've chosen rainbow, but we'll try a different one after. So let's hit F5 on our keyboard and look at that. Oh, that's pretty nice. So we've got this nice map of the United States with all the counties on there and the FIPS code and the broadband in 2017 showing the percentage that, of people that have broadband. So, on the West Coast here, lots of people have broadband. And some areas that might be more rural, they don't have quite as much broadband. And so you can sort of get an idea up in Alaska there. I think that's wilderness. But we've got some areas that have great broadband and some areas that are not so much. So that gives you an idea. This is a nice interactive map. Now we can change that hover over. You can format that. You can do certain things with this right in the browser, which is really great. You can see the broadband 2017 title that's above the scale there. And the scale has been created proportionally to the range color that we created there. So all of that was automatic depending on this field here, this broadband field. But we can change that to a different field in our source data set there. We could say per capita income 2017, and we could also change our color continuous scale here. If I could type, there we go, thermal. We'll change it to the thermal type and we'll take a look and see what that looks like. So now when we hit F5, so you have to Control S to save and then hit F5, and now we've got a different look at things using the per capita income for 2017 of each county. You can see some big variations here, and we still have that FIPS code in there. We'll add the name of the state and the county here in just a moment, but you kind of get an idea of what it looks like, and you can get a sense based on thermal of what the per capita incomes are. And so we might choose a different field and change things up here a little bit. Let's take a look at unemployment. Unemployment rate 2017, and that'll give us a different set of numbers. Again, we created this entirely dynamic with respect to where the numbers start and end, so it could be dollar figures or percents, it doesn't really matter. Let's see here. Let's pick something that has a lot of variation in it maybe. That solar looks pretty cool. Going all the way from that sort of dark color to yellow. So let's put in solar, and that'll give us a different output. We'll put our cursor in and hit Control S, that'll save it, and then F5 to run it again. Oh, that looks pretty cool. So there we go. We've got our unemployment rate, which looks quite a bit different. Certain areas have a very high unemployment rate. Other areas have a very low unemployment rate. You can hover over just about anywhere in the United States, and you can kind of get an idea of what the rates were in 2017. You can also look at Alaska here. There are different rates in Alaska and the counties there, and that is fantastic. And so you might be wondering, well, how can I add some more fields or some more data to my graph here or my map? And you can definitely do that. What we could do is we could create a new field in our source data frame, and we could call that county. So that'll be our county. We can maybe put the state name in there too. So let's concatenate some fields together here. We'll do our data frame state and comma, and then we'll do a we'll put in the county name as well, so that now we have sort of some more granularity. You could also just take these fields separately on their own, but I'll concatenate them just for an example. So we'll put data frame state and then a comma and then data frame name, which is actually the name of the county in that data frame, And so now we can put in our DFX, which is the subset of our big data frame. We'll put in that county field. So now we have a county field as well. You could create any other kind of data you want. You could put other data points in the hover over as well if you wanted. You could put the values of those. So you could hover over and show additional data points in that if you wanted to. But for now, we're just going to add the hover data argument, and we're going to create a dictionary here which will have county. So that's the name of that field, and we're going to say true. So we're going to make sure that we show that. So like I said, if you wanted to add other data points in there, you could certainly do that. You could show lots of different things. So let's hit F5 and let's take a look and see here. Okay, that looks pretty good. So now we have our county in our hover over as well. Some people might even remove the FIPS number depending on what you wanted to show. You might need the FIPS number for something. It really depends, but you can sort of see now. We can see this is our mean work travel, and as you can see, the mean work travel time is very different among these states here. It's kind of interesting to look at these. You know, in Nevada and Montana there, the times are quite a bit shorter than if you look at other areas. You can see it appears that the west has a shorter travel time, and the east here, the mean times are quite a bit higher around those big cities in Massachusetts and Connecticut and Virginia there. So you can get an idea of what's happening and make comparisons between regions on a map using the Choropleth map, and that's very, very handy. You can see it's easy to get sucked into looking at these things. Even with the little bit of work that we've done, you can get useful information using a Choropleth map. It's really great for comparing regions, and users really like it because it is interactive, and you can add all kinds of detail to the hover over. You can change the labels, set titles, and all kinds of things, and you can integrate this into other applications, and that's how you make a Choropleth map in Python.
Need to collect time for your staff and contractors out in the field? Make sure to check out my Build Zone system. The link is in the description.